This video is going to do practice problem 5.12 part G from the textbook, and what the problem asks you to do is to implement this truth table in VHDL using a selected signal assignment, and we're going to design the file, we're going to design this system, and then we'll simulate it with ModelSim. Alright, so this is a truth table we want to do. A selected signal assignment is another form of a concurrent signal assignment that is it's similar to a conditional signal assignment, it's just got different syntax, and sometimes it's more efficient to model. So here's our simulation setup. We're going to have a test bench called systemg_tb for test bench. We are going to design systemg.vhd, and the test bench is out on Desire to Learn, and it's expecting you to name it this, so that's why we always choose that name. And the test bench will generate the input patterns, and we'll look at the output using ModelSim. Alright, so let's begin. I'm going to go in and I'm going to create a folder for this design, for this simulation. Every simulation needs its own folder, so I'm going to call it systemg. And let's go out to Desire to Learn, and let's grab the test bench. So I come into practice problems, and out here you'll see VHDL test bench systemg, so I download that and I put it into this folder. Alright, we're ready to go. So now what I'm going to do is I'm going to bring up ModelSim, and now I'm going to start a new project. So I say File, New, Project, and I got to make sure I browse to the right folder. So if I go to systemg, there it is, and I'm going to call it systemg_project, and I leave the default library name work, and I go ahead and create this project. So now it's going to say, okay, you want to do a logical simulation. Let's get some files. So I'm going to add my test bench. So there it is, systemg that I just downloaded, and there it added it. Now I'm going to create a new file, and this is going to be my design file. And let's just verify that it's in the right place. So it is in the right place. So I'm going to come to the end, and I'm going to call it systemg.vhd. Alright, so that's my design, and I'm ready to begin. So I'll leave that truth table right there so you can see it, and I bring up systemg. Alright, so let's begin with the entity. So entity systemg is, and I do the ports, port A, B, C, mode is in, type is bit, and my output is F, and it's it's mode out, type bit, and I ended up. Okay, there's my entity. So I go ahead and say end entity, semicolon, and I'm ready for my architecture. So I come down, I say architecture, and I give it a name. I'll call it systemg arc, and I get of which entity is this behavior associated with. So I say of systemg, that's my entity, and then I say is. Now I'm ready to begin. So I just say begin, and I start doing my selected signal assignment to implement that truth table. So in a selected signal assignment, there's a little bit, it's really good because you give it the input name, you start it by saying with, and then you give it the signal name you're going to assign to, or I'm sorry, you give it an input, and then you say select, and then you make your assignments. So F gets something, so the first row would be 1, when, and then you give it the input, the code for the input. So like for example, I'd say 000 right here, and then I do comma, and I comma delimit then other conditions. So then I say otherwise you do it a 1 when 001. Okay, so I skipped over something here that's kind of important with selected signal assignments. You can only put one name in the input. Alright, so we need to do something here because A, B, and C are scalars, and I can't come in here and I can't, like, you know, combine them here, or I can't list them like A, comma, B, comma, C. I have to get one signal name. So what I'm going to do is let's just create a signal. Let's create a vector. So I'm going to say signal, and I'm going to call it ABC, I don't know, vector. And what I'll do is I'm going to assign this to be a type bit vector 2 down to 0. And I did that because what I'm going to first do when I start my behavioral description is I'm going to assign to it. So I'm going to assign to this the concatenation of A concatenated with B concatenated with C. And what that does is, all I did there is, this is just a little technique to group these together so that I have one name that I can use in this selected signal assignment. So if I say ABC vector, now I'm good. So that's the concatenation of ABC. Didn't really do anything. This doesn't do any circuitry. All it does is just gives me a name that I can use. So that's something you have to remember when you use selected signal assignment. And if you try to do any concatenations in here, you'll get a compiler error or a warning that says I don't understand what you're doing, so it kind of reminds you what's going on. But now what's nice about that is that I can describe the value of this vector as a 3-bit code, right? So then I come in here and vectors are indicated with a double quotes on the outsides. And look what I can do. I can actually write it in 000. So this is even more intuitive when you go directly from a truth table. And now what I can do is I can just start copying and pasting here. So I'll go 1 0, and then I do this one. So this is my first 4 entries. And notice what I'm doing here. I'm comma delimiting them. So I go 1 1 0 0. Okay, and then I'm going to do, let's just get them all. I'm going to do all 4 of these. Okay, and boom. So I come down, and now I've got, let's change my input codes. And then the output is going to be 1 0 0 0. Okay, let's check everything first. Let's see. So I got, let's check my input codes to make sure they're right. 0 0 0, 0 0 1, 0 1 0, 0 1 1. 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, good. So I've listed out all of the codes, possible input codes. Now let's check my outputs. 1 1 0 0, 1 1 0 0, 1 0 0 0. Okay, this is great. I got it in there. So now you're sitting here, you know, how do you end this? All you do is when you're done, go ahead and throw a semicolon on there. And since you've covered every possible input code for this, you're set. Now if you didn't cover all the possible input codes, the compiler will actually complain and it'll say, what are you supposed to do for this input code? But since we covered them, we're good, and we'll look at that in just a second here. So now let's end the architecture, semicolon, and let's see, did I spell that right? You know what, I'm going to leave it like that because we have not seen a compiler error yet. So I'm going to save this just to get a compiler error. And I noticed that I misspelled it because it didn't change colors. So let's go ahead and compile, and let's see what an error looks like. Compile selected. Oh, there's an error. Compile of system G failed. So I double click on it and it brings up the error. And so it says, okay, we've got some problems here. Line 24, labels do not match architecture. And it's like, you know what? I misspelled it. So I come in here, I say architecture, and it turned red, so I know that I at least got close. So then I save that up and I compile selected. Successful. All right, I got it. Now let's compile our, let's see, compile the test bench. It would work too. Let's load it up. So I go to library, I go down to work, and I'm going to load my test bench. I always load the simulation from the test bench. Here comes my waveform tab, and I'm going to add to wave all signals in region. And I go ahead and run simulation. I zoom full, and here I got it. So let's check and see if this is right. I'm going to go right for the group. So I'm going to group this together, combine signals. I'm going to call it ABC. And ABC, and then I say OK. I go ahead and nuke these signals, these scalars, and now here I have it. So I got 0 0 0 is 1 1 0 0 1 0 0 0. So that matched my truth table. Great. So let's change the radix and look at it as an unsigned. So radix unsigned, and this would be the equivalent of the row numbers. So I have a 1 on rows 0 and 1, correct, correct. I have a 1 on row 4, which is correct, and 0's otherwise. Done. I did it. Okay. Now, one of the really nice things about a selected signal assignment is how compact you can make the VHDL. So let's look at a couple other different ways you can do this. So I'm going to end my simulation, and I'm going to model this a little bit differently. So I have my selected signal assignment here. And what I'm going to do, let me comment this out because I want to leave it so I can see what I'm trying to do. You can use the keyword others to cover input codes that are not explicitly listed. So let's see how we do that. I can say with ABC underscore vector, and I use keyword select, and now I'm going to assign f gets, and I'm going to say, what I'm going to do is I'm going to say 1. I'm going to list out the exact inputs that correspond to an output of 1, and then for all the other input codes, I'm going to say otherwise just assign a 0. So I'll say assign a 0 when, and then I use this keyword others. So let's see how that looks. F gets a 1 when row 0, 0, 0, comma. I'm going to assign it a 1 when the input is 0, 0, 1, so that's row 1. And then I'm going to assign it a 1 when the input is 1, 0, 0. Now I say assign it as 0 when others, any other input code. So that is the exact same functionality as this. And what I did is I just explicitly listed the input codes corresponding to an output of 1, and then I said for any other ones, just do others. And this is nice because this will cover everything that it was not explicitly listed, so you don't have to go through and list everything. But we got to make sure that worked. So let's make sure that I entered that right. And so I save it up, come back to my project, and I notice it's changed, so I compile selected. It worked. Let's go into the library. I load up my simulation by double clicking on it. I got my waveform right there. I come over here, I say add to wave signals in region, and I run the simulation. I zoom full, and look, it's working. How do I know it's working? Well, let me do this. Let me group these, combine them. I'm going to call it ABC. I say OK. Come back in here, edit, delete. Okay, so I got a 1, 0, 0, 1, 0, 0, 0, and then it starts over again. I did it. It was the exact same functionality. Alright, so that technique worked very well. Now what I'm going to do is do even more compact syntax. So in my simulation, what's really cool about selected signal assignments is that when you have a common output for multiple input codes, you can pipe delimit the input codes. So let's take a look at how that looks. So let me comment this out. I want to leave it there so I can see what I'm doing. I come down here and I check this out. I come along and I say with ABC vector select. Alright, now I'm going to say this. F gets assigned a 1 when 0, 0, 0, and now watch this. Pipe, and what's that? It's like the equivalent of saying when 0, 0, 0 or 0, 0, 1, and then I do pipe, and then I do 1, 1, 0, and then I comma delimit it, and then I use 0 when others, and that's it. Now look at that, and I did it in 3 lines. So that's kind of slick too. So it's just very compact, and that can be useful when you get like large number of inputs. But we got to check and see if it worked, because first of all I typed that in wrong. It's not 1, 1, 0. It's 1, 0, 0. So we would have found that one in the simulation, but I just noticed it. Okay, so I saved it up. Let's go back and compile. Compile. Selected. Alright, it worked. So I'm all ready to go. I don't need to recompile my test bench because it compiled correctly before. So I load up my test bench. Here's my waveform. For some reason it went down there this time. Not sure what's going on there. Let me close that and I'll bring it up there. Okay, life is good. Alright, so there we have it. And I'm going to come over here, add to wave all signals in region. There's my 4 signals. I simulate it, I zoom full, and there it is. I'll go right for the grouping, so combine signals, ABC. And you don't need to combine these, I just do this so it's easier to see. I'm going to delete those, and here I go. 1, 1, 0, 0, 1, 0, 0, 0. And then I start over. Did it. So those 3 techniques all worked. So let me end the simulation, and I'll end the project here. But I come back, and I closed my VHDL file, so I'll click on the project tab, double click on that. So look at these 3 different techniques. All 3 are selected signal assignments. They're all equivalent functionality. It's just you get different levels of compactness. So that is a selected signal assignment. So I'm going to go ahead and my simulation's ended. I'm going to end my project. So I close my project, and I did it. I implemented that truth table with selected signal assignments.